So my next two sections here are forms and then persistent. How are people feeling? What do people want to do? They want me just hear me talk about this stuff for a while and just talk about forms and then work on the forms exercise? Or? I don't know.
Talk about the persistence?
It's either forms or persistent probably with the time we have left, right?
I don't think persistent. Yeah,
well, the persistent exercise, okay, well, I'll just go for forms really fast,
okay.
and then we'll talk about persistent more.
Plugins?
Auto form? Like,
That's that generate your form based on like type.
I haven't seen any derivable forms, but it's pretty nice. So I'll show you what forms look like. Okay, so forms, Yesod form gives us forms. You need the form. We've had this for a while actually. You need this form instance to use forms, but we had it for auth because auth has forms. This is actually because of internationalization stuff, because there's a whole system for having data type for messages, and each message maps to a string depending on what language you're in, and I think there's a whole interpolation for that. I18N. Yep. So you got all that, but that's not something we're talking about today. So fields, forms are going to be made up of fields. Each field defines a way to parse some input from the user into a Haskell data type, as well as, basically how to construct the input box in your HTML. And these are some of the fields. You got basic int fields, text area fields, password fields, and password fields, it's like a type password, so you get the stars and everything. Yep, so the types are, they take what, they're running in handler, not too important. But the main thing is, text field, return text, password field, return text area field, text area. It's a little bit weird. Int field's a little, it's parameterized on integrals, so any integral type it'll work for, that sort of thing. And then you can modify fields, so, if you have a field for ints, but you don't want them to be too big, or you want to specify like a year range or anything like that, you have some functions for applying a check on the value a field returns, and it transforms the field. So, yeah, and this is some silly field validation example, because you don't generally actually want to check if names are too short. But so you can just use normal check, or you can do like check bool to be a little shorter here. And then those are fields, and then you can convert fields into forms. And we're talking about particularly applicative forms. There's also monadic forms and input forms. But applicative forms get most things done that you need, and they're convenient. So the two main things, you have a rec for applicative required and applicative optional. So you can make a text field into a text form by making required. You give it a label. Well, actually, this is a field settings and but optional default value. So this would let you actually fill in like the value when they first load it. So if you like doing edit on an edit page, you can load in the old value with that. And it gets a little strange with optionals, because you have a maybe, but it makes things kind of cleaner to actually have that sometimes, or most of the time. So because it's an optional value for an optional value, basically. And yeah, these are some examples of default values. You can pass in the text and wrap and adjust and have a default value. This is what the field setting type actually looks like, but previously we were just putting in littles. It's an isString, overloaded string. So what happens if you just fill in like name? If you put in literal name, all it does is basically set that label and leave all these others empty. Nothing, empty. So field settings lets you customize things so you can have nice tooltips and things like that without getting too crazy. Or just put on arbitrary attributes to your HTML input. And you can also use SMap here to just apply some value to return of the applicative. But this is, silly. And then applicatives let us combine them together. So if we try to make like a person type here out of a text, their email, maybe a website, you just build it up from each individual field. So you have like a text field for the name, an email field for the email address, and an optional text field for the website. And then you could also apply some validation here to make sure the website looks about right or whatever. Then a lot of times it's kind of convenient to be able to include values not from the user here. So like if this is going to go into the database, you want to keep track of when it was created. If you want to keep track of who created it, or yeah. So basically, applicative forms, you can still access your handler functions in your applicative form if you just lift out that, because you're basically just another layer now above handler. Or you can lift IO, which looks a little strange, but this is just lift getting you into handler and then lift IO getting you back to IO to get these values, and they just fill in. So peer is just peer is applicatives, right? Yeah, good. Yeah, so it just gives you back, brings this into the form basically without actually generating any of the form stuff.
User ID is a function that you can use in the handler. What user ID is?
No, this is passed in here.
Oh yeah, sorry.
Yeah.
Is a form?
That's applicative form.
If it doesn't have instance of, it's not monadic form.
I think it is.
Then you should be able to just do lift IO.
Should be able to do what?
Lift IO without doing the lift IO. Hello.
Is it not a monadic transformer?
Lift IO.
You definitely have to do the lift IO. Or at least I'm pretty sure you have to do the lift IO. I think I have a type for a form. Yeah. No, I didn't do a type for a form. It's not terribly important. It's an applicative. It's handy. Actually, maybe you can do it once you turn it into, if it's a monadic form, I guess. That would make sense. Yeah.
So
Yeah. Yeah.
So where do you plug the post form into?
Yeah. Okay, we're getting there. Yeah. So first of all, though, how do these inputs get composed together? There are functions here that are type form render. A form render takes an A form and turns it into a form. A form is actually a little weird because it's an HTML to M form. So this is a monadic form, but it takes an HTML. And what that HTML is actually really just arbitrary HTML that gets thrown into the form. And what this is used for is so that the form system can insert extra input fields for you. So what it'll do is it'll have a CSRF token set up and will automatically insert. Do people know about CSRF? I guess some people definitely know it. So CSRF is cross-site request forgery. And basically the idea is you don't want someone to be able to, or some site that isn't your site, to put in a request, basically fill out one of these forms for the user and use their cookie to send it off to your server and change something about their data on your server. So the CSRF token prevents them from being able to just capture your cookie and do this, because it'll send you a different CSRF token every request. So it has to be just that particular request that you're responding to, and it'll keep that token around. So you have to send it back after you get it to make sure that they're the same on the server side. If that makes sense. So, yeah, so that's what that HTML is. Monadic forms you can do manually. You can basically write a function in HTML to monadic form, blah. You generally don't need to, but it does give you complete power, really. So if you don't want to have any, it lets you basically completely separate the HTML side of your forms and it's the styling from the actual getting of data for the form and filling. Yeah. So because when you actually take the M form and run it, you end up getting back a widget that you can embed in your page. Let's see. Yeah, let's just go up to here. So yeah, so if you have your form and you actually run your form, you get back a widget for it. Or if you actually, let's look at generate. So this is post and get, right? So if you're just getting a page with a form, you can run generate form post, and it'll give you back a widget and an enc type. The enc type is just to tell it how to encode the data sent to your system, to your server. But let's see, so if you're using a monadic form, you can basically construct whatever widget in there you want. When if you're using applicative form, you're limited by the vendor divs.
So the first those things for the form widget there was used in the template because if you go back, no,
Yes,
because we're not using it here. So
exactly. So a form widget doesn't actually include the form piece of the widget or the button to submit it. This is so that you could actually tack in extra stuff yourself as well. So it doesn't really finalize it for you. And then you just put the form widget in there, which has all your input fields, and give it where to submit it to, because you can, have your form served on a different page when you submit it to, all that. So you basically just specify that in the HTML. Yeah. So the interesting thing here that I skipped over briefly is here we're doing generate form post, and then here we're doing run form post. Run form post actually checks the environment, your parameters and whatnot for the actual data for the form. And it will get a result from that, put it in res. There are form success, there's like form empty, there's like form error and form missing, I believe. But generally you only match form success and anything else. On form success, you can do some database stuff, which I haven't gotten to yet, but this is if your entry is of one of the database types, you can just insert it like that. Set a message, redirect them. And then otherwise, we have this failure case, basically. If the form failed, we go back to our previous page, right, the form page, and just display it again. And the cool thing about run form post is that it'll actually, the form widget will actually have the failures kind of in it. So it'll actually show the user which fields have failed. So if you have some validation in there, it'll tell them which fields have failed validation, or just that were empty when they were required, or things like that. So basically, you don't have to do any of that manually. It's all there, unless you're doing something special. And if you're going to do something special, you can use Monadic Forms and do everything special. But the interesting thing here is this and the fail case is basically the same as new post are. And if you run a get on a run form post, and I should specify here, so the post here refers to what actually submits the form. The form is run on a post, not whether we don't specify, this doesn't change depending on if we're in the get or the post handler. Because you can also run a form on a get, but that's how we specify which one. We put that in there. Is it? Oh, okay, it's there. But yeah,
So I'm kind of curious, is that that result, can it be anything other than a form success or a form failure?
Yeah, there's like two things down here. There's like form, like fail and form missing. There's like a form fail where it's like a list of all the failures, so that it can plug those into the form. And so you can know about them and display them yourself, I believe.
So in that,
But in this case, we just do them the same. Yeah.
Refresh the thing to show the failures. Yeah.
Exactly, yeah. Because we have to serve them something or redirect them somewhere. I mean, I guess we could also just redirect them back to the Git page, but
Yeah.
then they wouldn't get any of the feedback.
Yeah.
And feedback's important. So, but since we have this be the same as this, the cool thing is that run form post is, if it doesn't find anything, it's just going to be a fail case with a missing form, which doesn't actually change the form. So we can just say get new post is the same as post new post, and it behaves the same, which is really pretty handy, because most of the time this is how you do a form. You have this get and then post chain here. So usually you can do this and you save yourself a handler.
And the names are post, new post, are it's just conventions, or is it something that needs to match certain pattern?
Well, so new post star is just the resource.
Yeah.
And then
but the fact that you have get and post in front of it, is it important?
it is, yeah.
Okay.
So when we have our routing declarations, and we've always had those just have Git after them so far, and that's just specifying what methods are allowed. But it also specifies that it'll call the Git method is the same thing as the other ones.
Okay.
Yeah.
And so you have, okay, sorry, that's not like that.
I'm not getting, maybe this was discussed, but post has obviously things about forms and stuff, but get can't. So how can we use?
Well, you can still. Well, it depends on the type of form. You can still have data for a form on a GET request because you can still have parameters in a GET request.
So,
URL parameters.
They go into the URL.
Yeah.
yeah, but okay, so
So you can't submit a form body during.
yeah, but you're also doing, okay, maybe this is HTTP stuff, but you're also doing insert into a database.
Yeah,
Typically not what you would get, right?
that's a post.
And I'm saying,
But we never hit that case in a GET.
Yeah, when you do a
That-
get,
that-
you have to-
Yeah. This form will always return like a form missing case, so it'll always fall back into this case. You can't have a form success
okay.
if they're getting the form and you're running it only on a post.
right. But I guess in this case, though, specifically, we are still doing a new post. Oh,
Yes.
sorry. Okay.
Yeah, we're not updating a post.
Get new post. I see what you're saying.
Yeah. Okay.
Be just calling the different handler. It's not necessarily. There's not necessarily having to do like doing weird stuff with HTTP calls or anything like that. You're just saying use this handler in the case of a GET.
Yeah. What I didn't get was that it defaults to the case where you're creating a new post.
Yeah, exactly. I didn't catch that.
The default layout do not, if that was the body of JSON.
Yeah, that's it. Yeah.
Yeah, it returns other results.
Yeah.
And could you replace that? Or is that?
What do you mean? I'm saying these are the same.
Yeah. I mean, if you didn't want to play that trick.
You don't have to play that trick.
Right. But there's still, it's not correct. So I was just saying, pull that out.
Yeah, you could break this out into a separate thing. But the problem is, your widget file here could require things. I mean, it does require your form widget and your ink type. So then you have to pass those through and stuff. It's just easier to do it. Yeah.
I get if you ran each one, it would actually suggest that. No,
But it wouldn't know about all
that's true.
all the variables you need to pass through.
It was like 3 lines and say, hey,
Yeah.
It looks like
Do yeah. Yeah, so some fun on the spec forms. There's also identifying forms. You can, if you have a couple forms, you want to make sure that you only get the form that they actually submitted. So if you have one handler that can handle multiple form submits, you can use identify form to basically it's like a form transformer. It puts in a new hidden field identifying what form that belongs to, and then it makes sure that it only gets the one that matches. And then there's the monadic forms. I'm not going to show you monadic forms. They're actually pretty ugly. Like really. But you run into them sometimes, but not very often. And you can actually, so a lot of the times I think that you could use a monadic form. It makes more sense to write a new render function. Because the render function is, taking your inputs and then it's going to put them together in some way, So either with like divs and labels next to them, divs without labels next to them, or like in a table. So I think in a lot of cases, if you want to have a unified style that's different than these defaults, it generally makes sense to just write a new render function that puts these together in a way that you like, styling you like. And there's actually a couple more of these. There's like a render bootstrap to get all the bootstrap. But I've sort of come to hate bootstrap for no reason. But yeah. So we're going to do that. But you kind of wanted me to talk about persistent, right? So yeah, general purpose, and it's not. Yeah, it doesn't even actually really care if it is a database persistent. But you know, if you have nice backends for MySQL, Postgres, SQLite, Mongo, you can run a Mongo or you can run an SQLite in memory, whatever. But basically, the problem with interacting with the database is a whole nother layer where we have to deal with, having untyped data on the one side, maybe not, safe data on one side. So it's kind of like another user that you have to deal with, because it's another place where you're getting stuff from a table that's mostly coming at you with text, or not nearly as fine-grained typing as Haskell. And yeah. So if you have like something in Haskell where you just have like a person that has a name and a age, you might have a SQL table that looks something like this. So you got an ID here, first of all. So you need to handle IDs somewhere. You have names, and we got this whole variable character, not null deal. And you have an age, which is an integer. So, fairly close, but you don't want to have to create all these tables and then handle marshalling yourself. So persistent is really nice. Basically, if you want to do this in persistent, you have this is your declaration. With a few lines of code elsewhere in the application, you pull in this. It generates Haskell data types to access these. It generates separate ID, new type, to reference which row in the table it's in. It's using some crazy, well, no, that's a different thing. But and then you have all these nice functions that basically just work on any persistent data type. And oh, okay, good, yeah. So this generates something that looks kind of like this. It actually, unwraps our types here. It generates a new type for a person ID, which is a key for a person, which is actually backend specific, right? Most of the time in a database, this will be like an int64. And then there's GADTs here, which I'm not going to talk about much, but basically this gives us a way to tie the fields in our database to our table, or to our particular data type. So this lets us have things that talk about a particular column of our table. Then lets our functions to select thing, do a select query, know the return type that it corresponds to. So we know this is basically saying, this person ID field, which is equivalent to roughly to a column, corresponds to a person table, as well as the person Haskell data type. Yeah.
I have a question regarding that.
Yeah.
ID, that is a key, that is database specific. If
Yeah.
you wanna, for example, in Mongo, each collection you can set the type for the ID yourself. So you could maybe use the string on one and int on another. So can you customize that per type? Like,
I'm guessing not.
no.
Persistent, no, it doesn't force int, but I'm guessing you can't customize it between tables of your backend.
Set it globally.
Yes, I believe it's specified for the backend. And if it's not the one, yeah.
The other thing is the name, the column name, for example, in SQL database, or the field in a document in MongoDB.
Right.
It seems like it derives both of them. So, for example, can you go back to the
This,
so
yeah.
name, age, and all those so far looks like they're all small case.
Good.
But if I wanted an uppercase or a capitalized version of it, would it even work?
If this was capital, the N or the A,
Yeah.
that means something different. So I would.
The reason I'm asking is if there's an existing database that I want to connect to.
Yeah.
Right?
So that actually, if it's capital, it refers to a uniqueness constraint. So, in an entity like this is saying that you can uniquely identify a person via the data constructor person name with a first name and a last name.
No, no, what I'm asking is the column names. Let's say I'm connecting to a database or
Oh, you want different Haskell than SQL names.
Yeah, exactly.
Yeah, so there's both a thing that can change to determine how it translates these into your SQL names. There's also additional bits you can put at the end here to directly specify exactly the column name, which is very handy if you have an existing big tables and systems. Yeah, they can't not give us that, right? Yeah, I don't have that in my slides.
So I have a question. Is this doing more sort of code generation?
Yes, yeah. So I mean, that's what this is. This is some segment of the code generated when from this entity definition with a Carl later that I haven't pulled up yet. Somewhere. Yeah. So it's generating the Haskell side, and then yes.
And is it also generating SQL code as well to run on that?
Yeah. So I mean, these will actually eventually. I think I mentioned it, but you also get nice features like automatic database migration. So just persistent will automatically do safe migrations if it can. So let's say you introduce a new table or a new column in your table, it can automatically migrate it and change your table definitions in your database to be the right table definitions. As long as you're not losing data, it's pretty conservative. So a lot of times if it'll kind of tell you can't do it. If you ever losing data, or if your constraints don't match, like if you already have a column and you want to add a constraint that's, let's say actually, so these can be maybes, so you can do like string maybe, and that's specifying like a nullable basically in the SQL too. So if you do something like that and then you want to remove the maybe, if you already have something there that's null, it won't let you do that. But if you don't, then it should let you do that.
Is there a way of writing more like a migration script to force that? Or
Yeah, I think there's like a hard force option potentially. Well, eventually the database will sometimes like not yell you. Like the database system might complain.
I didn't mean like just to overwrite and clobber it, but like in the situation where there's no clear like automatic upgrade path, is it on you just to go upgrade your database on your own? Can I add a band, or does
Usually
have a
So I mean, persistent gives you the power to run raw SQL queries, so you can do whatever you want eventually. But that's not the way you want to do anything, right?
Well, depends what we're doing.
Well, generally, I mean, do you ever actually want to?
I don't mind SQL at all.
Yeah, well, exactly.
If I want to set a bunch of defaults and things that are null in a table, that's pretty straightforward SQL.
There are some corner cases though that you do need to run raw SQL, like stored procedure stuff generally.
Yeah.
Or that would be very nice for that.
Yeah, and actually, when you want to optimize your tables, it does become kind of handy because, a lot of the optimization things you do once, you tell it which things you want to do, and then it does it from then on.
So and I like instead of the default.
What?
Instead of its default SQL it would generate, you can tell it what SQL to use. Is that what
No, that's not what I'm saying. I'm just saying you can give it raw queries.
Oh, I see.
Yeah. I mean, you could actually write a new backend, a new SQL backend, that does things differently, but you're no longer really in the same backend. Yeah. So yeah, so let's say we have a couple like we do our maybe here, so it's like a nullable age. And by the way, the deriving show, just so we can print it here, you can actually drive other things as you would for the Haskell data type. And then you have like blog posts, titles, and authors. And here we actually refer to the person ID. So the person ID was generated because we have a person table, and this refers to a particular person in the table. Then we can do simple inserts really easily. You can just give it a Haskell data type. And it's one of the Haskell values for that data type, and it'll just insert it. Insert gives you back an ID for it. You can do the same thing, blog post, no problem. Then this is kind of what a select query looks like. I have a lot more slides on this in a little bit. But this is saying here that I want blog posts where the author ID is equal to John ID with a maximum of one of them. And then, for instance, I don't have an example of it printed out. But this type signature here is unnecessary. It's just there for doc. Most of the time, persistent is very, very good at figuring out the types. I don't know if I've ever have it not figure out types, because again, each one of these types. So these are the sort of things that are being tied back to the table type, so that now the type inferencer can say that, oh, from this select list must return this list of entity people. Now an entity blog post. An entity is basically just a pair of an ID for a row and the actual value that's been stored there. And it's kind of a question of whether you want to store your ID in your Haskell data type. Makes a lot of sense not to, I think, because if you do like an insert query like this, if you store an ID in there, you don't know the ID until you run the insert, and you gotta, yeah. Get lets you just get by an ID, easy. There's update queries. This is setting this person age to a new value. And you got delete, and you got delete where, right? So you can delete all blog posts where John ID is or where the author ID is equal to John ID. You can delete the ID itself, you know. So a bit more about selects here. You have quite a few options. The whole first section, you know, is your where clauses basically. What are the restrictions on your query? And you got all the general numeric comparisons, stuff like that. If you just have it in a list like this, those are all ANDed together. When you want to do an OR, you do the bar dot. And this is a consistent theme in persistent operations of what you'd expect with a dot at the end, for the most part. Didn't I have an example? Find an example. The only thing that isn't what you'd expect for a Haskell programmer is, I think, not equals. They went back to exclamation point equals because they use slash equals somewhere else. I don't remember where. Yeah. So, you know, you got example, people between 25-30 or 35-40. First name Gavin, first name, these are member basically. Is the first name a member of that, or is the first name not a member of that?
Just like in.
In, yes. Yeah. Now select list right now, we've just used empty list back here. These are the second list here describes limits, offsets, sorting. So these will all get as many as many entries as follow these constraints.
Is the slash before the James Albert mean not in?
Yeah, not in. Yep. There's a select first, which will just give you back the first thing that it finds, matching a constraint. I think this actually takes a second argument, like all these other ones. I think I just forgot to put that there when I look at it.
What is the second thing for?
Well, that's what this side is there, yeah. But I just put this bit here in to show, select first is a maybe because it might be an empty list. If it is something, then I just wanted to show the entity because it's entity and then just the ID for the thing and the actual data value. So yeah, this is just one big example to show you pretty much most of the things you can do for the second list. So you can sort, and this is actually ordered. So first you'll be descending on the person age, then ascending on the person first name if their ages are the same, ascending on the person last name first, then first name if the last names are the same. Limit to, so this is kind of a pagination system where 10 results per page. Depending on your page, you always want at most the number of results per page, and you offset it by however many pages you are in, times 10. So this lets you get chunks of 10 of things that match over 18 in a very specific order. A little bit more about updating. So you saw replacement of a value. There's also basic numerical operations where you can do plus equals dot, minus equals dot, times equals dot, divided equals dot, which is why you have to use bang equals dot to handle not equals, because they have divide equals here. So yeah, so you can update things incrementally like that, so you don't have to worry about, well, mostly it's actually convenience, mostly. Because if you have several of these in the same database runner situation, these will actually happen all as one transaction. So it's not really about transactions or anything. You can do updates where, so update everyone. There should be quotes here. My name's not a data type. Yeah, constructor. And then sometimes you need to replace an entire entry, and that's what replace is for. You just replace an ID's entire value. And that's mostly actually pretty handy in Yesod when you're doing edit forms. If you have a form that's been loaded with the default values from the last entry in the database, then when you actually get that form back successfully, you can just replace the previous ID completely with the value from the new form. Because if your new form is already creating your database type, you don't have a whole lot else you'd want to do.
So I'm assuming all of those would return like
nil.
unit,
Not nil.
Unit.
Unit. Thank you.
Okay.
I keep saying nil.
And is there one that update and return the updated document?
Yeah, no, I
no
see what
longer
you're
is
saying.
Like find and modify or something. So, and then it modifies it and gives you back either the not updated or the new value.
Right. I don't feel like I've ever seen them.
I guess it might.
MongoDB, like MongoDB.
Yeah. So yeah, I guess it might not be available in other backends, so maybe that's why it's not included.
That could be a reason. So persistent's kind of conservative because they support a very large range of backends. And I think like Redis, you can Redis this or something. Backend. No, maybe one of those other ones. One is one of those big memory stores.
Yeah, it's like
Cassandra?
React, that kind of thing.
Possibly. I'm not entirely sure.
You said you could sequence these, or you could do a bunch of them, and they would basically be done in a transaction.
Yeah. So yeah, there'll be a bit where, at least in the handler, right? You will run. You have a separate function you run to run a chunk of database code into the handler, and that whole thing will run as a transaction. So this will, yeah.
So you said they're returning unit, so that means are they not monadic? Like we're not sequencing them with do?
No, you would.
Okay.
They have a returning unit in a monad.
Oh,
These are like a reader T type.
Gotcha.
I wish they had a nice type synonym, so I could be like, oh, it's just database. Yeah.
Are these create and update statements? Are there like callbacks and are there like implied columns of created at, updated at that are also getting updated as part of all of these statements?
So again, that's kind of backend specific. Like most, databases offer something like that, but I don't believe persistent offers any interface for something like that. I'm actually not sure if I know if Haskell others would offer persistent like that. Of course, you could. I mean, that seems kind of honestly anti-functional.
Yeah, that's true.
So you could just write, nice little functions and do all the things you need. I mean, admittedly, there are points when database automatic triggers are important, but I don't think there's really any modeling of that. Yeah. Deletes. You can delete by an ID. Obviously, you can delete where. You can even delete where on an empty list with no conditions to just delete everything. But in that case, it doesn't actually have any way of knowing what table you want to delete. So you do have to type annotate that. Because it's using these, person first name to determine that, oh, hey, this is the person table.
That will be deleting everything.
Yeah, it'll delete everything in the person table. Exactly. Yeah, and then these uniqueness constraints, we have these, which let us do things like get by. So we can get an entry by a uniqueness constraint as long as we know there's only one. right? And that's what the uniqueness constraint does. And then the SQL backend can enforce that for us.
So the uniqueness part is just saying person name, first name, last name.
Exactly, yeah. And then it's used in the Haskell as a data constructor. And in the backend, it's been actually implemented as a uniqueness constraint.
Yeah, so what kind of SQL does that turn into?
I'm honestly not entirely sure. I'm not that familiar with SQL. I do Postgres, but I don't dig into triggers or uniqueness constraints too much. And in relationships, we already saw we had we referenced a person ID from a blog post earlier. Here, kind of models a many-to-many relationship with a separate table for mapping them. Now, the trouble here is that persistent actually doesn't give you any good way of doing an SQL join. Actually, the best way persistent does it is actually to do this manual SQL. This is because, again, the backends aren't just databases, and joins really only make sense in a database system. So sadly, yeah, persistent doesn't give you a good way to do joins. And if you want to do joins, you generally, if you want to do type-safe joins, you then get upgraded to Esqueleto, which is a type-safe DSL, which is much more database specific. It's actually backend specific too. So you'll have the Esqueleto Postgres implementation, and then you're writing what looks an awful lot like a SQL query in Haskell. So you'll have select thing, you have where, and then some crazy dollars and other things scattered about the place to get all the order of right. It's not that pretty, but it does give you type-safe joins in SQL. And so that way, if you know all the types of everything, it's really quite nice for that. It also gives you some nice benefits in other ways, because the big other problem is, so far you've seen we've done selects and gets and things like that, and they've all returned entire entities, right? And the issue with that is, say we're getting 10,000 entities. Let's say we decided to store small PNGs in our database, base 64 encoded. I know. They're still pretty big, and you're doing a big query, but you don't actually need those images right now. If you do that query, with standard persistent here, doing a select list or something, you will be pulling all of those base 64 encoded images into memory that you have selected, which is really pretty bad.
So is there any way to project fields?
That's what Esqueleto is for. So yeah, I was leading to that.
This one doesn't even let you do that.
Yeah, no, because again, fairly restrictive it supports a lot of things.
Yeah, backend has to support that.
Yeah, it's a little annoying, but for for a lot of things, this is really convenient. But then it kind of falls apart eventually. But But the nice thing is, the Esqueleto is still based on persistent and persistence types, so you can actually intermix. You don't need to choose one or the other. You can use this for all the stuff you can get away with it on, and then when you need either to project out things to save space, or when you need to do SQL joins, things like that, you can then move into Esqueleto.
So, and then just while this is up here, and you might be getting to this, it's like select list. Are there other containers, or is that kind of, like you have a list of persons, right? And
Yeah.
then people, something persistent would handle, or would you would need to do that next?
Yeah, I haven't seen anything that's like that, honestly. It's all select list. It's kind of funny.
There's not like a select vector or something.
Yeah. I'm not sure. I'm trying to think if there's a very good reason for it, though. It's possible you're just limited elsewhere. Because I'm not actually in deeply enough to this to really understand the interface layer between this Haskell and the actual database backend or other backend.
Only there were people at this conference who were.
Yes, if only. Oh, wait. Thanks.
No, we could seriously get them on Saturday.
We could do that. That would be pretty cool.
And I'll find out.
That would be cool.
Yeah.
We're going to do that.
I mean, Chris is doing Escalado and Michael everything else.
Conduits. You can talk about streaming with responses and stuff. That's pretty cool. Because actually, you can actually do cool streaming from the database stuff with not too bad code. Let's see. Constraints, relationships. Right. So when you're actually using Yesod, like in the actual scaffolding, like if you pull in the PostgreSQL Yesod scaffolding, you'll have something like this, and this is loading config models. This lowercase settings is what's doing how this converts over into the SQL table names. So let's see, how does that actually convert? That means, yeah, I think it just does this snake case. I think that makes it snake case in the SQL. Yeah, but there are a few options there, but that's it like that. And then here this make persist that generates the actual persist types, and the make migrate, which actually makes this migrate all function that is the function that allows you to migrate over to your new database, or rather new table representation when you update your tables or whatever, and you haven't, and you want it to try to migrate your actual table. You want to have a connection pool because connection pools are great, save you lots of issues. And then you have a couple of instances again. So instances, that's how you extend Yesod, right? RunDB is the main thing. So RunDB takes this action. This is the monad that we're actually running that all those functions are in, delete, etc. It's the reader T. And then it's getting from the con pool, the connection pool for the database, and actually running that action in the SQL connection pool. And then you have some database configuration settings, initializing the pool, performing database migration. All this stuff that is given to you again. It's just in the scaffolding. You really don't have to write any of this, ever. And then there's also a couple of extra convenience functions provided by Yesod, rather one of the extra bits of library that allows you to do things like get 404. And what these let you do is, you're trying to get by an ID, but if it doesn't exist, normally your get would return you nothing or something. But why not just 404 over now, because that's what we would do anyway. There's also a get by 404, so no problem, right? So creating a listing, of entries from a table in a database is pretty simple, because you can just run a select list, get a bunch of entries. You can, have particular restrictions, but you can also just sort them.
So that displays a list of people.
Yep, list of people from the database who are in ascending age, and then it just matches them all. And then actually, this is for generating links to them. So we have each person's first name, and then it generates that's a link to that person resource.
When you click, then it's going to display the actual data.
So this is very a common pattern here, where you have handlers. Once you get a database backend, you have handlers that take a database ID, and you get a 404, and then you display a content on that. It's very, very common case, yeah.
By the way, I've been a terrible concierge. The keynote's starting in like 2 minutes.
Oh, right, I'm supposed to end early. I forgot I was supposed to end early. Okay, well that was my end.
People aren't like upset at what you've been saying in the last 5 minutes.
Yeah, no, but this is the end. So just looping over entities.